Welcome back to Geometry Classroom. Today we'll talk about cross sections of three-dimensional figures. We have two main objectives for this lesson. So, students will develop spatial visualization skills through creating cross sections of solids, and students will sketch solids that contain given cross sections. Now, what is a cross section? A cross section is the intersection between a solid or three-dimensional figure and a plane or bidimensional shape. A cross section is the face that we obtain, right, by making a slice through a solid object. A cross section is, as I said earlier, a two-dimensional shape, usually. And I know we've seen a lot of cross sections in real life. Like, for example, a slice of bread, right, is a cross section, right? A slice of cucumber, right, is another cross section, and so on. Now, how we make these cross sections? If the plane that cut the object, right, is parallel to the base of the object, right, then the cross section is horizontal. If the plane that cut the object is perpendicular to the base, then the cross section is vertical. If the plane that cut the object is oblique, then the cross section would be oblique. Now, as a rule of thumb, and we have to remember this rule, the maximum number of sides of a cross section cannot exceed, right, the number of faces of the solid that is cut. Yes? For example, for a cube, right, the number of faces of a cube is 6, right? Which means the cross section, the maximum cross section of a cube, right, is a hexagon. So, in other words, a cross section of a cube cannot be more than a hexagon. Let's talk about a few examples of cross sections of different solids. Let's start with prisms. In this slide, there are a few two cross sections of a triangular prism, right? This is an horizontal, right, cross section for a triangular prism. As we can see here, the plane cut the triangular prism, right, horizontally. The resulting shape of the cross section would be the same as the shape of the base, which is a triangle. If the same triangular prism is cut horizontally or parallel to this base, right, the resulting cross section would be a rectangle, right? Another case is a cross section of a cube. When we cut a cube horizontally, the resulting cross section would be a square. If we cut vertically a cube, the resulting cross section is the same, a square, right? Because all faces are squares. But what happens if we cut a cube uh, oblique, right? Like in this case. As we can see, the resulting cross-section would be a rectangle. And this is not the only shape, right, we may have. As I said, the maximum number of sides of a cross-section for a cube is 6. So we may have even a hexagon, right? Good. Another example is cross-sections of a rectangular prism. As you can see, if we cut this rectangular prism with a plane parallel to the base, right? Yes. The resulting cross-section is a rectangle. If we cut horizontally this prism, right? Again, the resulting cross-section is a rectangle. This is an interesting cross-section. If we cut the corner, yeah, the rectangular prism at the corner, right, oblique, right, the resulting cross-section would be a triangle, right? Good. Another example is cross-sections of hexagonal and pentagonal prisms, right? This is an horizontal cut, right? So the resulting cross-section would be a pentagon, right? Is the same as the shape of the base. If we cut oblique and hexagonal prism, as we can see, the resulting shape, the resulting cross-section is a hexagon. Good. Let's move on to another type of solid, pyramids. I prepare for you a few cases of pyramids and their cross-sections. For example, for a rectangular pyramid, if we cut this pyramid by a plane parallel to the base, yes, if we cut horizontally, right, the resulting shape would be a rectangle, right? Is the same as the shape of the base. If we cut the same rectangular pyramid exactly through its apex, right, the resulting cross-section would be a triangle, right? But not always. When we make a cut through an object like a pyramid, the region where we make the cut matters. Why? Because I'll show you another example. Look, if we cut this rectangular pyramid by a plane that is perpendicular to the base, but not through its apex, as we can see, the resulting cross-section would be a trapezoid. So depending on how we make the cut, we may have different shapes. But remember, the number of sides of the cross-section cannot exceed the number of faces of the solids, which is, in this case, 5, right? Good. Another case is the cross-sections of a triangular pyramid. As we can see, if we cut a triangular pyramid vertically, right, through its apex, right, the resulting cross-section would be a triangle. If we cut horizontally or parallel to the base, the resulting cross-section would be also a triangle. But if we cut, let's see if I have, no, I don't have that slide. But if we cut oblique, right, this triangular pyramid, we may have other shapes like a trapezoid, right? Remember, the number of sides of the cross section cannot exceed the number of faces. Let's talk about another interesting solid and its cross sections. Look at this shape. This object is called cone, right? And if we cut this cone by an horizontal plane or parallel to the base, right, the resulting cross section would be a circle, right? Is the same as the shape of the base, which is a circle. But if we cut the same cone vertically with a vertical plane that passes through its apex, right, the resulting cross section would be a triangle. Now, but what happens if we cut the same cone by a plane that doesn't go through its apex, like here? As we can see, the resulting cross section is a parabola, right? Pointed downwards. Another possible cross-section shapes. As you can see here, the plane that cut this cone is oblique. So we may have a different shape, like an ellipse, right? If we cut by another plane, like this one, yeah? So the resulting shape could be even a hyperbola. So we may have different shapes. Good? I'll show you another solid and its cross section. This is a cylinder. Again, if we cut a cylinder horizontally, right, or parallel to its basis, the resulting cross section is a circle. If we cut a cylinder vertically with a plane perpendicular to its basis, right, the resulting cross section would be a rectangle. Good? And probably the last solid and easiest one is a sphere. Whenever we cut a sphere by a plane, right, the resulting cross section would be a circle, right? So cross sections of a circle, of a sphere, is always a circle. Good. Let's have a few examples. In this example, it says which figure has the same horizontal and vertical cross sections, right? If we look at A, right, this is a rectangular pyramid. Its horizontal cross section, right, would be a rectangle, right? And its vertical cross section would be a a triangle. For a sphere, the only cross section is a circle, right? Here we may have a triangle or a rectangle. Here a circle. Here, for a cone, right? A vertical cross section would be a triangle if that cut is made through its apex. For a horizontal cut, the horizontal cross section would be a circle, right? And for a triangular prism, the vertical cut would be a triangle, and an horizontal cut would be a rectangle. So, the only objects that have the same horizontal cross section and vertical cross section is A and B, right? Good. Another case, another example, which figure does not have a triangle as one of its cross section? Now, A has a triangle as a cross section. Why? If we cut vertically through its apex, right, this rectangular pyramid, right, the resulting cross section, right, would be a triangle, right? Is a triangle. Here, if we cut vertically this triangular prism, the resulting cross section would be a triangle, right? And also here, if we cut vertically this cone, right, the resulting cross section would be a triangle. But there is no way to get a triangle as a cross section when we cut a sphere, right? So the answer is C, right? Only for a sphere we never get a cross section in the shape of a triangle. Another case, another example, problem, practice problem. Which is the vertical cross section of the figure, right? So when we cut this object vertically, the resulting cross section would be a rectangle, right? Or a square, yeah? This is a square, yeah? This is the square. Good. Another example. Which is the horizontal cross section of the figure shown? Now, horizontal cross section means cutting horizontal, right? Parallel to the base. In this case, the cross section would be a square. Yeah? Look here. Has the same shape as the base. Another example, and probably the last one, which is the vertical cross section of the figure shown. Again, when we cut vertically or perpendicular to the base, the resulting shape is a triangle, right? If the cut is made through the vertex or apex, right? But this problem also could have this one as the answer. Why? Because if we cut this square pyramid vertically by a plane that doesn't go through its apex, right? Like here, right? Now, the resulting shape could be a trapezoid. Yes? But the answer is a triangle. Now, that is all we have for this lesson. We'll have another lesson soon regarding similarity of solids. Thank you for watching my video.